So, after discussing about application of digital human models in different industries, now we are going to discuss digital human modeling in industrially developed countries. In industrially developing countries, it is found that digital human modeling and simulation is not that much popular and its application are very limited. So, why this digital human modeling software is not that much popular, or what's the reason behind this less adoption of this technology? Developed countries are widely using digital human model technology for manifold applications and have realized immense benefit. The use of digital human modeling technology is still in nascent stage among many developing countries, including India, as reported by Sangjog et al. 2012. Digital human model tools require substantial monetary investment and training, which can be afforded mostly by large resourceful companies in developed countries. So, one important reason behind this less adoption of this technology is the initial investment. At the beginning, for purchasing the software, installing software, training of the manpower, then overall infrastructure setting, it requires huge cost, and this investment is many times it's not possible for very smaller industry or micro, small and medium scale industry, and this is a bottleneck for the developing countries or underdeveloped countries for this adopting this technology, because those companies or factory owner are unable to afford this technology due to the high cost. The majority of small medium scale industries are still unaware about the digital human modeling tools, as reported by Santos et al. 2007. Not only the cost is involved, there is other factors like lack of awareness. So many of the industry, they does not know about this importance of this software and how this software can be used for better man-machine interface and for improving the overall manufacturing systems productivity and performance. Lack of awareness is another factor contributing to the negligible application of this technology among fast developing countries or fast developing economies like India, Pakistan, Bangladesh, Russia, Syria, Thailand and other similar countries. The low rate of progression in adoption of advanced computing techniques might be important factor behind less use of this CAD and DHM in many developing countries. So, in this various authors highlighted what's the reason behind less adoption of digital human modeling based virtual evaluation system in the developing countries. Now, here I have tried to tabulate the use of digital human modeling software in various developing countries like Indonesia, Malaysia, Brazil, Egypt, China. Although China and India are moving towards very rapidly progressing towards developed country. Right now it is in the transition phase, both the countries. It is moving from developing condition to developed to the status of developing countries. From the developing countries to the status of developed countries. Now, if we look at this table, then the number of publication or reported literature from those countries are very limited. Particularly from, if you look at Indonesia, only few literatures are available. Similarly, from Malaysia, the number of reported research which has been carried out in Malaysia, that is also hand countable. In Brazil, the number is relatively more, but not that much in comparison to other developed countries. But in Egypt also it is very less. But in China and India, good number of research is being carried out. But again, if we look into those countries, the publication is mainly coming from few research groups. It is not widely spread all over the country, or in most of the academic institution or research institution are still not adopting this technology. So these are the references wherefrom I have made the table. Now, DHM related research and development activities in India. Now, particularly we are going to highlight the application and research activities related to DHM, digital human modeling and simulation in Indian scenario. So, if we look at application oriented reported research, then we will find that there are good number of reported research available from India. So, here I have tabulated. So, first reported research area. So, in this column we have mentioned the field of research, and this column describes the name of the authors or the reference. So, application oriented digital human modeling is being applied for various workstation evaluation or product evaluation or in different types of industries. So, that has been tabulated here. So, for example, evaluation of workstation in aviation by Pinto and Taneja 2005, work posture analysis by Mohan et al. Then the interior design of long haul truck cabin for improved human well-being by Power and et al. In 2009. Then design of the spatial layout of equipment in playground by Karmakar 2011. So, in this way we will find other publications related to ingress egress from vehicle, then anthropometric size measurement of Indian driving population, reconstructing a solid model from 2D scanned images of biological organs for finite element simulation by Kumara 2011. So, in this way we will find that good number of publication related to application of DHM are available from India. The list is being continued here. So, modeling for anthropometry, case study for vision analysis in air cockpit, 3-dimensional whole body scanning, then automotive ergonomics for urban warfare, occupant packaging related, then road accident, proactive ergonomics for product design innovation, evaluation of manual material handling, exploration of ergonomics problems and design solution in a drinking cup. So, in this way we can find almost 18 publications. Although all those publications are not in a good journal, many are in conference proceedings or not in referred journal, but this is the overall scenario, and we can find, although India is a big country, only 28 numbers of publication we can find as of 2016. So, this number is very less in terms of the size of number of institution, numbers of research organization in India. This number is very less. So, total 28 publication I could have found out. Similarly, while we are looking at research and construction of digital human modeling, person or researcher who are involved in developing digital human model or the whole digital human modeling software or the digital human modeling structure or its individual body parts like hand modeling, foot modeling or head modeling for protective equipment. So, in this way, if we see the research related to digital human modeling, model development and construction, the number of research reported from India are also very less. Only 11 publications we can find out, and most of the research are also by only only from one or two research institutions or research organization. So, overall spread in this area, that how digital human modeling can be made better and how this software can be improved. So, in this direction the research is very limited. in Indian scenario. So, to mention a few research activities related to hand posture inspired from classical mudras by V.P. Nair in 2008, then a vision modeling framework by Vinayak and Sen 2012, then visually guided hand reach by Bhatia et al. 2015. So, in this way, only very few research papers we can find out. Then, while we are moving to review based, various researchers who have reported regarding the application of digital human model or digital human model construction, ultimately review paper. The review paper written by also very few authors from India. So, total number of review papers as of now we can find out, this is also 12 only. And in these review papers, so authors mention various aspects of digital human modeling like CAD and digital human model for computer interaction assessment by Mukhopadhyay et al. 2012, digital human modeling approach in ergonomic evaluation by Rajput et al. 2013, application of DHM in agricultural engineering by Patel et al. 2013, then virtual human modeling and simulation in textile industry by Kumar et al. 2014, research towards achieving high fidelity evaluations using DHM by Reddy et al. 2014, use of DHM in Indian scenario by Karmakar et al. 2014, virtual ergonomy for aviation and aerospace sector by Sangjag et al. 2015, and the recent one, user centered approach using CAD and digital human modeling in agricultural sector. So, in this way only hand countable research papers are available which deals with the digital human modeling and its application, but mainly these are related to review. These are review based papers. Now, this is important to understand then what can be done, as in India and in other developing countries this digital human modeling it is not that much popular and its application is also very limited. Then how it can be, what steps can be taken for widespread adoption of this technology in developing countries. So, first, awareness among researchers, scientists, engineers, designers and entrepreneurs could achieve through organizing seminars, conference, workshop, etc., as mentioned by Karmakar et al. 2014. So, one way of achieving this goal of widespread adoption of digital human modeling technology in developing countries may be through awareness. There is need for collaboration among various industries, academic institutions and government or private organization all over the world under one umbrella to advance virtual technology, mentioned by Patel et al. 2016. Strategies for wide adoption of digital human modeling technology in developing countries like India should include integrating features of digital human modeling tools in general CAD software, which may result in reduction of cost to some extent. Generally, digital human modeling software right now commercially available in the market, if we look at those software, so its capability of creating the workstation model or the overall virtual environment which is needed to be evaluated, the capability of these softwares are very limited in that regards. It can create digital human model, it can create the whole workstation in virtual environment, but its capability as a CAD software for generating complex model and very big file containing all the parts file and assembly file for the whole work environment, that is very limited of the presently available software. So, if we can integrate digital human modeling tools in general CAD software like CATIA, Unigraphics, SolidWorks, then it will be easier. So, only buying one software will serve the purpose. Otherwise, right now what is happening, you have to buy digital human modeling software separately and CAD software separately. You are making the CAD model of the product or workstation in that CAD software and importing that model to digital human modeling software for virtual ergonomic evaluation. But if these two can be integrated, then only one software will fulfill your purpose. Research initiative for development of user-friendly digital human being software and making mannequins more realistic with incorporation of mannequins representing Indian anthropometric dimension should be required, as mentioned by Karmakar et al. So, if for the, like, to make this technology popular in a country like India, one important step that anthropometric database of Indian population to be incorporated in the digital human being software. So while people will use that, or researchers or designers or engineers, while they are using this digital human being software, they can directly create digital human model from that inbuilt anthropometric database. So it will be very useful for them. Subsidizing digital human being software initially to make it more economical and accessible. As we mentioned earlier also, the cost of this software and initial investment is high. So if government or some other funding agency can subsidize this software, then it will be good for the researcher to adopt this technology, and it will be easier for them to use this type of software for their academic activities or for research purpose. Digital human model still need to fill a significant gap with creation and emerging body or technical society dedicated for advancing and popularizing the use of virtual technology like CAD and digital human modeling to solve real world problems. This is also mentioned by Karmakar et al. 2014 and Patel et al. 2016. So this type of technical body or technical societies are to be established, which can take initiative for popularizing this virtual ergonomic evaluation technology throughout the world, including the developing countries. So these are the references from where we have prepared the slides. So as we mentioned, there are so many references. So all these references are tabulated at the end. So who are interested, the students who are participating in this particular course, I suggest all of them to go through all these references. You can download these papers and can go through to get better idea about what type of research is going on presently in India related to its either the application of digital human software or related to its development. Now, what's the, as we mentioned in our the first slide, that in this particular module, in module 8, we will discuss about limitations of presently available digital human software. In the market, there are so many digital human softwares are available, commercially available, and but all those softwares have some limitation. Mainly, most of these softwares actually allow virtual evaluation or virtual study. No subjective evaluation is possible. So in this slide, I have listed general few points regarding the limitation of presently commercially available softwares. So first one is that as the analysis is virtual in nature and no subjective evaluation is possible, so that is a big limitation. Effect of physical factors like temperature, humidity, illumination, noise, and how these affects human performance in workplace, that cannot be studied with this commercially available software presently available in the market. But research, obviously research is going on in this direction. In near future, probably it will be possible. And few softwares have already incorporating these features. That so we will discuss in next section, that is related to future research scope of digital human software. Simulation results may vary from software to software since the analysis is based on algorithm, and that algorithm is also depending on statistical model. So that is also another limitation. So how that software will perform, that is actually depending on the which algorithm is incorporated in that software and how is the reliable the statistical model which that particular software or that modeling or simulation software is following. All analyses are based upon different algorithm which derived from statistical model, as I mentioned earlier. So, as this analysis is based on different algorithm, so the output of the analysis, how effective or how reliable the analysis is, that is also dependent on the what type of algorithm, which software we are using, and in that software the background algorithm, how much strong or how much reliable is that. So, depending on that, the ultimate output is will be achieved. Positioning mannequin with appropriate working posture, that is also time consuming and many a times difficult. So, in this direction also advanced research is going on. So, many softwares have already overcome the problem, and in many, even few commercially available software right now, it is very easy to position digital human model on the respective, or interfacing the digital human model with the respective products or workstation model. Another important aspect is contextual knowledge is important for successful ergonomic evaluation, and many a times it is found that there is lack of contextual knowledge, and due to that the overall evaluation is being suffering. Accuracy of analysis not only differ from real human subject and digital mannequin, but also from the mannequins generated by different software. So, we can also find that there is very accurate in terms of accuracy while we are doing the analysis with the real human subject and mannequin. There is some difference. Not only this difference, there is also difference while we are analyzing through different software. To software, all the one digital modeling analysis of one digital modeling software is differing from analysis done by another software. A frequently faced problem is the prolonged duration for file conversion on the building and on the building of virtual environment. So, it takes enough time for file conversion, but as the computing technology is advancing day by day, so it will also be possible in near future, it will be possible in shorter time. Incapability of analyzing multiple mannequin activity at a time, such as in case of assembly process. So, in assembly process, while so many workers are working together, at that time their interaction is very important, and we need to evaluate that how people are interacting with each other, and during that time we need to go for various types of ergonomic evaluation. But right now what is happening with all this digital modeling software, mainly we can evaluate the various ergonomics aspects of work activities for an individual or for a single mannequin. For multiple mannequin, the analysis is not possible simultaneously. So, you have to complete the analysis for one particular mannequin. After that, you have to move for the next one. So, these are the general limitation as is observed with the presently available digital modeling softwares. Now, in the subsequent slides, we will discuss about the report or the statement by various researchers regarding the limitation of digital modeling software. So, Lattus 1998 mentioned or reported that the people develop a very repeatable behavior or style in reaching motion, but this pattern is quite specific to a particular person. So, during the reach analysis, they found that for a real person, the pattern is quite specific for a particular reach activity. Such individual variation is difficult to accommodate in many of the existing digital human models. A study carried out by Oudenhuizen and Jenner 2000, they assessed anthropometrics of mannequin softwares in terms of accuracy. Results showed that accuracy not only differ between real human subject and mannequin, but also among mannequins generated by different softwares, as you mentioned in earlier slide. Bigler 2000 showed in his research that a small variation in position and action of mannequins will lead to wide variation in response. Hence, positioning of mannequin with appropriate posture is very important, which is difficult and time consuming. For many of the digital human doing software, giving appropriate posture to the digital mannequin and positioning the digital mannequin on the respective workstation or seat or chair or any other working place where you are putting the digital human model for ergonomic evaluation. So, this positioning, appropriate positioning with appropriate working posture, to do that one, it takes enough time. So, that is also a problem in many cases. But as the technology is being advanced, so in many of the software now it is possible to, because he has reported in 2000, but now in 2016, after this almost 16 years, now for many of the commercial software it is possible to position digital human model very quickly. And also there is posture library. From posture library we can directly go for a specific posture. The increase in number of calculation performed during simulation raises the risk of software failure, and many times software hangs also. The effort invested in developing an environment and an associated evaluation procedure can be quickly lost in a software crash. Because many times we need to put a lot of effort for developing the environment, and at that time if software crashes, then you will lose the whole effort. Hence, he suggested that higher computer configuration is required. And so this is very important for digital human doing software or CAD based work. So high-end computer with very good configuration with good graphics card, good processor, that is required. An apparent side effect of increased processing power has been an increase in the overt functionality of these tools. He also mentioned as the increased processing power is required, at the same time while increased processing power is available with the advancement in technology, then the software developer, they have incorporated a numbers of features, and during using those features it is actually increasing the overt functionality for use the tools. Then it is many times it is difficult to find out the tools or menus for simple analysis. Some of the digital human modeling software use inverse kinematic algorithms for posture determination and analysis. These inverse kinematics methods may not be biomechanically very sophisticated, and they can result in erroneous postures of the mannequin, as reported by Chaffin et al. 1999, and thereby affect evaluation. Existing softwares are not well capable of predicting realistic and varied population postures and motion. Cavellars et al. 2000 mentioned that the designers should be aware of the anthropometric differences between countries or population to population. CAD programs are limited on the types of preset mannequins available, which can vary on percentiles within the specific population. So, first problem related to many of the commercially available digital human modeling is that the number of anthropometric database which is preset is very limited. So, if the software is being used for a particular nation or particular population, if that anthropometric database is not incorporated in that software, then many a times it is difficult by the user to creating the digital human model. So, it is one important requirement is that, so the digital human doing software or developer of the software should incorporate maximum number of anthropometric database as much as possible, so that that software can be used all over the world. Because if the particular anthropometric database, say for example, if Indian anthropometric database is not incorporated in that digital human modeling software, then if that software is being purchased by researchers from India, then he or she will not be able to use that software. He can use, but then it will be much more easier for him while the anthropometric database is already incorporated in the software. Otherwise, he have to collect the anthropometric data. Based on that data, he have to calculate that percentile values, and based on that percentile values, they can create percentile digital human model, or they can also use individual anthropometric data, and based on that data, they can create a digital human model. Positioning the mannequin is a major problem, as reported by other researchers also, as it both difficult and time consuming, and thus there is a great need for robust and simple posture and motion prediction capabilities. Inaccuracy of position and movements can sometimes make huge differences. So this was reported by Chaffin in 2001. But right now, in many of the software, it is very easy to position digital human modeling software, to position digital human models, or interfacing the digital human model with the product model or workstation model. Incorporation of ergonomic analysis model such as RULA into mannequin software leads to the risk that the user may employ the model inaccurately, being unaware of its limitation, background, and so on. For this reason, to implement successful ergonomic evaluation, contextual knowledge is very important or very much essential for both design engineers and ergonomists. So, contextual knowledge of ergonomics is very essential for successful use of digital human modeling software for virtual ergonomic evaluation. Otherwise, the use of digital human modeling software for various ergonomic evaluation will not be fruitful. Chaffin 2005 identified that there is lack of data sharing capabilities, thus requiring a designer to spend a great deal of time or extra time for rendering a workspace or workplace with enough detail to perform an analysis. Many times it is found that data sharing capabilities of the softwares are also limited, and file conversion from one software to another software, there is also problem. Because in a particular software, we can import only some specific file format. So that's why only we can import those files which is compatible for a particular software. So data sharing capabilities of these softwares is needed to be increased. Another limitation of present-day digital human modeling software is the incapability of analyzing multiple mannequins activity at a time. We have already discussed this one. Blanchonnet 2010 found that the digital human modeling software could be suitable for tasks like ergonomic assessment of a cockpit, but not that much suitable for assessment of personal protective equipment of a pilot. So while we are evaluating any particular general product or workstation, then that is easy. But while we are going for evaluation of personal protective equipment, then specific face model or head model or specific hand model is required, which so right now this commercial available software is not that much suitable for this purpose, for evaluating personal protective equipment or personal equipment to fit a pilot or any other working condition or workstation scenario. Allender and Khalid 2012 stated that when using digital human model, it is possible to make a task look feasible, but when translated into manufacturing environment can only be accomplished with high level of discomfort. So from digital human model analysis, it seems that probably this is feasible, but in real life while it is being implemented, then various other problems are being encountered. So physical discomfort is indicative of poor biomechanics, which can contribute to the development of MSD. So more biomechanical features, biomechanical analysis features to be incorporated in digital monitoring software. So Allender and Khalid also stated that the requirements like functionality, attractiveness, ease of use, affordability, aesthetics and safety that will evoke emotions, especially depend upon cognition, are not considered in DHM. So various aspects which is mainly dependent on cognition of the human, those aspects are not presently incorporated in digital modeling software. The discomfort levels while completing the task have to be inferred by designers or engineers. If possible, representative users such as those that will be directly interacting with the structure should be consulted about perceived discomfort level of the structure. So while designers or engineers are designing a particular product or workstation or any other facility, that time evaluation of digital human modeling through digital modeling software is okay, but at the same time it will be good if we can at the same time take feedback from the representative users, because the subjective evaluation is not possible. Various like affordability, aesthetics, safety, so all these aspects which are related to cognitive performance of the or cognitive aspects of human being, those things can be evaluated with the representative user population. So small representative, with the help of small representative user population, we can evaluate the overall the concept model. Initially, we can evaluate with the digital human modeling software to find out the anthropometric compatibility or biomechanical compatibility, but for various subjective evaluation purpose, we can call for representative users. Johnson and Fletcher 2012 concluded that because of limited anthropometric database, there is a need to create large anthropometric and biomechanical database of various population across the globe. Creating a mannequin of a particular percentile of interest is time consuming process. So they also highlighted these two aspects, that anthropometric database for defined population, that is required, and at the same time many a times creating a particular percentile mannequin of a particular percentile is time consuming. When modeling the posture of mannequin while interacting with the product, the postures adopted through the task from beginning to end should be modeled. Many a times what happens, we only identify some key posture and evaluate those key postures only. But for some activities, the working posture may be judged as acceptable by posture analysis tool, while MSD risk lies in the transition postures, not during the transition from one posture to another posture. So only identifying key postures for a particular activity and evaluation of those postures in virtual environment may not fulfill our purpose. So for that purpose, each and every step of the specific posture as well as posture transition postures we need to evaluate. It was also found that subjective evaluation is not possible, only objective evaluation is possible. Hence, inputs or suggestion should be taken from individuals outside. As also mentioned by Allender and Khalid, the representative users are required. So Johnson and Fletcher, they also mentioned the same thing. Individual, so representative users population is very important. Ideally, this would include representative users. So inputs and suggestions should be taken in terms of subjective aspects. Those inputs is needed to be taken from the representative users. In their research paper, Johnson and Fletcher reported that there is a disconnection between what a designer perceives and what is possible within the manufacturing environment. Any concept or solution is limited by the perceptions of the people who are working on the design. Those designers are engineers. So the concept is limited or constrained by their idea, their perception. For this reason, representative users' inputs is essential to identify the problems that may be missed in CAD-based design using digital human modeling. So these are the various aspects, various limitations of presently available digital human modeling softwares and reported by various researchers in their research paper. And these are the references